Hi, welcome to another edition of Design Spark Ask the Expert. Today we're going to be talking about data comms, data communication and installation, and why that's important for running an efficient operation. Today's expert is Robert Lighton from Fluke. Hi Robert, would you like to say hello to Design Spark?
Yes, of course. Hello to everybody, and thanks, Greg, for inviting me over.
Great. So Robert, data comms is obviously very important for running a slick and efficient operation, but could you just explain to me a little bit more about why that is so important?
I guess the network and the data communications that run over the network are like the cornerstone for a lot of organizations out there, maybe even all organizational. Continuous uptime is critical, and I guess if you think about the impact of connectivity issues, like in companies that are working in financial services or also in the manufacturing, industrial automation, then the cost of downtime is extremely high. So, yeah, datacom up and running, very important. And I guess also, as we have seen with the COVID pandemic, when a lot of people had to be working at home, how important it was that the network infrastructure was working.
Yeah, that's a really interesting point. The the working from home hasn't really ceased in the UK. There's still a lot of people working at home, so that good infrastructure is definitely needed. So, if we were talking about the users or installers regarding data cabling, what is it that they need to be thinking about?
Yeah, I think that, if there was multiple aspects to look at. There was obviously the installer one, but maybe to first start with the end user. Well, I think what they are particularly concerned about is the actual performance of the network, that they basically get what they have paid for. And certainly also that there is a warranty running on the cabling infrastructure that has been installed. And keep in mind that these manufacturer warranties, they can go all the way up to 25 years. So that is like an insurance, if you wish,
Mhm.
that is in place. If you then look at it from the installer perspective, obviously customer satisfaction is important. Uh, but if there issues arise, he wants to make sure it's not his problem. So from another perspective, when an installer does a job, they also want to make sure that there is a proof of good workmanship.
Yeah.
And the certification of the networks that maybe we want to touch on that a little bit later, but then the certification of the network plays an important role in both the warranty for the network and ultimately the invoices that are there to getting paid. I think also, is if you think about fiber optics, there is another very important aspect to look at, because in the world of networks, everybody was very much used to ensuring that the networks meet the specifications that are mentioned in the cabling standards. Now, when it comes to fiber optics, that is almost like not good enough anymore. And it has to do with the deployment of these ultra low loss components.
Hmm.
There is connectors there that if you look at them from an OTDR perspective, the optical time deflectometer perspective, then the reflections that come back from an angled connector, the so-called APC connectors, is almost very similar to that of a splice. So if you apply the normal loss budget that'll go for a connector on that, then basically, they're too wide. So making sure that you comply with the latest requirements from the cabling manufacturers is then also extremely important to ensure, again, the performance and also to make sure you get the warranty. Perhaps there's one other thing that is interesting in the world of fiber. Also has to do with these ultra low loss components, and that is from a practical perspective. Anytime you do a measurement, goes for copper twisted pair as well. You need to set the reference.
Yeah.
The reference basically means zeroing out the connecting hardware so that you're actually testing really the link under test. And the setting the reference in copper is a pretty simple process. In fiber, it's a little bit more complicated, although there are wizards that help you guide through that. But traditionally, it was like, set it once a day. That's good enough. In the morning before you start, you set the reference. But nowadays, because of these very tight limits, that has gone down to multiple times per year. And I was hearing not so long about a Microsoft project where the installer actually had to set the reference once every 1.5 hours. So once an hour and a half, every time set the reference. So that is another important trend that we are seeing.
Yeah. So you're saying, so for fiber optic, the infrastructure testing would be tighter than the limits than those specified for the industry standards. Is that good practice? Is that what you're saying? Yes.
Yes.
Yeah.
So that obviously it depends on what kind of components are being deployed. But if you think about the data centers, then the bandwidth is critical, right? Network needs to be as fast as possible, and that's when the specs as they are in ISO 11801 and that kind of stuff is simply not good enough anymore. So then custom limits come in.
Right. Okay. So when it comes to types of testing within datacomms, could you just explain what they are?
Well, if you think about again, we need to differentiate between copper and fiber. If you think about copper, then everybody, I think, is very comfortable with testing copper cabling, probably because it's highly automated. In reality, there's actually a great deal of parameters that are being measured, and some are actually calculated as well. And then there is other things playing a role in the world of copper as well, because we see an enormous growth in the area of power over Ethernet,
Hmm.
where there's power being supplied over a regular, twisted pair cable. And especially with the growth that we're seeing in the Internet of Things, and also the IIoT, the industrial Ethernet of Things, you see a lot of devices which maybe do not consume even that much power. Frequently, devices also located into a little bit difficult accessible places. Think about security cameras hanging outside high up in a wall, or access points which will be attached to the ceiling.
Yeah.
So this power over Ethernet that basically means that you have a low voltage connection, which is one, and the second one is you don't need to get an electrical installer in to make a power outlet at those places. So
Yeah.
you see good amount of growth in that area, but to make sure that the network can handle the power over Ethernet, there is a parameter called resistance unbalance that needs to be measured as well. And the funny thing about this parameter is, it's a parameter that's been there forever, but it was never part of field testing.
Right.
And of course, a good number of years there was basically no power over Ethernet. And when it first started, I think it was somewhere in 2002, 2003, when the first power over Ethernet appeared. But the deployment was really low. Now that it's becoming more and more important, we are seeing that more and more field test requirements include the resistance unbalance parameter.
Yeah.
And our instruments have had it since 2013, I think. But that is also an important one. And the last one that I think when we talk about copper is actually shielding. And of course, every tester shielded cabling gets deployed. So every tester, when shielding gets deployed, has a shield test, but that shield test is like a DC test. So if one end of the link is connected and the other end happens to be loose, then it'll still say that the shield is connected, but you really want to have the test capability to test if both ends of the link are connected. Because if it's not, then there could be a substantial loss in electromagnetic immunity, so EMI, that could go all the way up to, I think, 10 to 20 dBs. And because of that, there is another parameter called the alien crosstalk, which will then become non-compliant.
Yeah.
And a lot of people have tried to stay away from the alien crosstalk specification, because to measure it is a little bit complicated. But this shielding, if you don't test it, then you could have those kind of problems. And
Yeah.
that basically means that like you have crosstalk where pairs within a cable start influencing each other. With the alien crosstalk, actually different cables start influencing each other. So that could have pretty bad implications for performance. And again, when I'm thinking about this, I think mainly data center kind of applications.
Yeah, so it's definitely important to make sure that you maintain the integrity of the data of the cable. Absolutely.
Exactly. Yeah. Then if we think about more like fiber, then it seems that some people are a little bit afraid of fiber, or they talk of like that as this black magic kind of stuff. And I always like to say, to me, fiber is actually a lot simpler than copper. Because with copper, I need to know about return loss, a near-end crosstalk, alien crosstalk, power sum next, and so on and so on and so on. While with fiber, I just need to know what the loss is and what the length is.
hmm
So that's, to me, that's a lot of it, a lot simpler. Now, there's a couple of issues with fiber that gets heavily underestimated, I think, by a lot of users, is contamination,
hmm
right? And, single mode fiber has a core which is 9 micrometer. Multi-mode is larger, but it's only 50 micron. So even a human hair would be large compared to that. And just a little bit of dust will actually mean that the fiber stops working. So if fiber it is, it either works or it goes dark.
Yeah.
And a lot of people say, I just connected it. Everything is new out of the box. That's not working. Yeah, but if they left the dust cap off, then that could be like a serious problem. Or if they happened, and I have seen people clean a fiber optic connector by rubbing it against their shirts. so, so that is not going to work pretty well. So yeah, and then the testing itself. Yeah, we spoke about the industry standards and the custom limits. Now, the basic certification process. You typically need a power meter and a light source. And for multi-mode, you typically use an LED source. And for single mode, you need higher power, and that's why they use laser sources. If you want to do this a little bit in an automated fashion, you actually use optical loss test sets. The Fluke Network 30 Fiber Pro is an example of that. And these test sets can actually measure 2 fibers simultaneously. If you just lose a meter and a laser source, then you actually need to start switching things around to make all the connections, because you need to do bidirectional measurements, but light in a single fiber does not travel bidirectionally. It only goes one way.
hmm
And with these optical loss test sets, you can automate that. Also run the test at multiple wavelengths, and these tests go really quickly. So then you know what the loss is over the fiber, and what the length is. So basically, you're good to go. Now there are, or I should say, there is a so-called extended certification possible. Sometimes it's also called like the tier 2 certification, which means that you go and look at the trace with an OTDR. And the reason you want to do that is to actually see if there is any components which are like marginal or maybe even out of spec in an otherwise compliant link. So the end-to-end may be okay, but it could be a component somewhere along the way where there is a problem. And especially if you have patched channels, also those you see typically a lot in the data center, where a link consists about multiple sublinks, which could all patch together. Then there is the loss budgets actually run up because there's a lot of different components in there. So it's a good practice then to actually shoot a trace with an OTDR, see if that is okay. I know also some installers that actually, before they start the certification process, they actually shoot a trace with an OTDR also to see if there is anything strange along the link. But ultimately, the OTDR is like the ultimate troubleshooting tool. It's been around for many years, and it's still a very desirable tool to have as an installer.
Okay, great. So just in terms of fiber, then, just interesting to hear about what you were saying about if there's any sort of like dust that can impede the signal down the fiber. But in terms of termination in connectors, you need to pay particular attention to that. Is that correct?
The connectors are the terminators at that point, right? So you connect them to the instruments, and in the world of OTDR, you do that with launch fibers.
Hmm.
And these launch fibers are designed to basically enable the user to view the first connector and the end connector. Otherwise, those would not be part of the test. And obviously, the both the front connector and the end connector are extremely important
Yeah.
connectors to test. And when you do the regular loss testing, then you use test reference cords, and the setting the reference procedure in those cases extremely important.
Great.
These need to be very high quality kind of test leads.
Yeah.
There's terms in there that for multimode people talk about encircled flux compliance launch conditioning, which means that the light is precisely injected into the fiber. And the loss over these test leads may be no more than 0.15 of a dB. Yeah, so there's a very important how you connect it, obviously. Yeah.
So, in terms of guidelines on choosing the right category of cable, if we're looking at things like network speeds, immunity and shielding, etc., what what guidelines would a user be looking at?
Yeah, it's an interesting question because I guess everybody wants the best performance at the lowest price. And yeah, from that aspect, that is simply not possible. So a lot of it turns down to what do you want to do with the network, right? So if you look about a regular office building, and then even category 5E will probably still work properly. So a lot of category 6 cabling will typically be installed there. What you also see happening, and I know, for example, in a country like Germany, that happens extensively. So they install category 7, or actually I should say class F cabling, and then they terminate it with connectors that are lower cost to keep the cost down. And obviously, if the cables that run into the wall are of the highest quality, the cost of the cabling is not so much different, but the cost of the connecting hardware is where the biggest chunk of the money goes to. So if they then need to upgrade them, then that becomes relatively easy. The other aspect is, if you think about the higher bandwidth applications, like how often are you going to upgrade your copper hardware before you switch over to fiber?
Hmm.
And what you see happening is that a lot of customers, they try to get extended life out of the copper. But if you ask them a couple of years later, they said, "Oh, I wish I would have upgraded to fiber earlier." And yeah, these are trade-offs get made, and basically it becomes a business decision.
Yeah.
Unless people have sufficient funding, then they do that. And now there is a new trend that I thought is also interesting to talk about, and it has to do with the Internet of Things, and specifically also the industrial Internet of Things, because there you have a lot of sensors which don't require any kind of serious bandwidth. It's stuff that replace 4 to 20 milliamp transducers as they were being used in the past. And there is a new development there which is called single pair Ethernet.
Hmm.
And the only reason they're really talking about single pair Ethernet, in my opinion, is because the cable is cheaper. So it all goes down. Yeah, so this cost aspect plays also an important role. Yeah, so not a straightforward answer there, but yeah, think about the speed that you absolutely need. And again, in my home, I'm sitting in my home here, I still have Cat 5e cabling. And believe it or not, but I can run high definition television from Netflix on my 4K television without any problem. So it tells you that the performance is cable is pretty good.
Yeah,
If
absolutely.
it's not good enough, then you need to switch to fiber. And but fiber is more delicate to install. Dirt plays a role. People need to know. Basically, they need to know what they're doing.
Yeah, yeah.
With copper, you can bend it around and throw it around and touch it everywhere, and it'll work.
More robust, absolutely. Yeah.
Yeah, so I don't see a lot of fiber like in industrial applications coming.
No.
Although the noise immunity could be a reason to use fiber also in those kind of environments.
Well, that's an interesting point actually, because it may be, over the period of time that you might be better off with fiber rather than copper, I guess.
Yeah. Well, I remember dealing with the Dutch military many years ago, and they insisted on relatively low bandwidth applications on fiber, mainly because nobody could listen to what was going on.
uh, we touched on this earlier. We talked about certification of data comms networks. How's that carried out, for example? Do you have any kind of examples, like in installation, for example? Is it best to test before you start installation, or can you just give us some guidance on that?
Yeah, so the process itself, you could say, is pretty much highly automated. And when I started working with Fluke networks in the late 90s, I always found that the installers that are out there are really technically pretty skilled.
Hmm.
I can tell you, I learned a lot from these guys. And what I notice is that today, the people actually operating the testers, uh, how can I say this nicely? They have a lot less technical affinity, right? And the people that had the real knowledge, they have been promoted to,
Hmm.
product manager, managerial kind of roles.
Yeah.
So what we have found through market research that we have done, that there is actually quite a bit of testing to the wrong limit that happens, or label IDs that get entered that are incorrect. It means that you can no longer track, where links go, and this testing to the wrong limit. With a certain frequency, I get questions like, "Unfortunately, we tested to the wrong limit. Can you correct this for me?"
Hmm.
And I go like, "Yeah." So if you have Cat6 cable and you tested it against Cat6A limits and it passed, then you can say you're good.
Yeah.
But if it's the other way around, I'm sorry, but you'll have to redo the testing,
Yeah.
which is obviously very painful. So when it comes to this work, I guess it's highly recommended that the one with the highest project knowledge actually takes the time to set up the tester correctly.
Yeah.
And testers nowadays, they can store up to like 100 projects in there. And as the tester then roams from site to site, the right things can be recalled. There is cloud services that keep track, where one team stopped and where the other team needs to continue. And then that it's basically an assurance that the testing is done and the labeling is done correctly. And this whole labeling, and in addition to that, you also need to print the labels to stick onto the cable.
Yeah.
And nowadays, also the project manager entered that in the tester software, goes up into the cloud, and there is multiple label printers that make connection to the cloud, download the label IDs into a smartphone or directly into their tester or a PC, and then they basically have the correct labels right there, and they cannot make any typos and so on. So there's a lot of efficiency enhancements which have taken place in that.
Yeah. I guess that's really important, isn't it? Is to make sure that it's right first time, and obviously with using the cloud servers where you're labeling the IDs, you can make sure that that's actually done correct the first time.
Right.
Yeah.
Again, testing this, especially this testing to the room limit, can have dramatic impacts on the profitability of a project.
Absolutely. We always used to say that the most costly thing was actually going back retrospectively and doing it again, rather than, if there was a small mistake, the whole thing needs to be tested again. It's not just a case of that one mistake needs to be redone. It could be the whole installation.
Yeah, and maybe one other thing that I didn't talk about before, but sometimes there is a pass, because everybody wants to go to a pass, right?
Mhm.
Yeah, the measurement pass, so I can move on to the next one and say, yeah, but there is also the so-called pass with an asterisk. And the pass with an asterisk are so-called marginal passes.
Yeah.
That means it's within the limit, but it's kind of on the limit, right?
Yeah.
So, and I would also, in those kind of things, recommend to basically troubleshoot the link,
Right.
because these things are likely to go wrong over time, and then you get then you have a callback, and if you need to travel all the way north in the country because there's a call, there's a problem somewhere with the link. These are all things that you can easily avoid by setting up the right standard work, if you wish.
Okay. I guess my next question is then, so what does a datacomms test engineer need in his toolbox? My kind of thinking on this would be termination tool, signal and source, verification, and network mapping capability. Is there products that you can maybe bring to the table that you can just talk about?
Yeah, the most popular product that we offer is actually a system. It's called the Versa Cabling Certification System. That is basically a platform where you have modules that get inserted into a main unit. The main unit is called a Versa. If you slide copper twisted pair modules in there, it becomes a DSX cable analyzer. If you switch fiber optic modules for loss testing in there, it becomes a CertiFiber Pro. If you slide an O to the R module in there, it becomes an OptiFiber Pro. And if you attach a camera to it, it becomes like a fiber inspection system. And the nice thing about that is that the user interface is universal. So you don't need to train a user on all kinds of different instruments.
Mhm.
Yes, it is all kinds of different instruments. They all have a common user interface, and they all report into the report with using the same documentation system. So that means that the whole process of data consolidation and producing the final reports, which need to get submitted for the warranty and also for invoices to get paid from the installer, is like very much simplified. So I would say, with that, the installers go a long way. I also see end users, particularly in the data center, buying these kind of products because they have a desire to be able to check one-on-one what the contractors have done that they brought in to do the jobs.
Mhm.
And the second thing is, if they need to do troubleshooting, then, it's great tools that they have there to actually do that troubleshooting. And the user friendliness and the intelligence built into the tester also plays an important role, particularly in the data center and enterprise world, because there these testers don't get used on a daily basis. It could be that they sit on the shelf for multiple months. With the installers, I always say, these guys buy these testers not because they like them. They buy them because they make money with them.
Yeah.
So I think these are that is the big thing. The other thing you probably, especially nowadays, want to have is a cloud account, because the days of driving test results back to the central office,
Yeah.
the days of losing USB sticks or data these are over. Get the cloud account, everything is there. You download it back and forth. The connectivity, there's Wi-Fi built into these machines. You make a connection to your smartphone, or you're connected to an access point that you have there.
Yeah.
So these are the ways actually to get it going. Then if you're more like in the system integrator area, so you're actually connecting things to the network as well, there is a new product category that Fluke introduced a little over a year ago. That is the Cable Plus Network Tester. Link IQ is the name of the product. So this product makes it possible to verify the actual cable performance up to 10G. And the interesting thing is it also performs power over Ethernet testing. And it doesn't just interrogate the tester and ask, or sorry, interrogate the switch and ask, what kind of class are you? Because there's all these different classes in power over Ethernet, and each specific class is able to run to a certain amount of power, with class 8 being the highest at 90 watts. But this Link IQ is actually able to load the switch as well.
Right. Okay.
Because you got all these ports on
Yep.
the switch, and not all ports can provide the maximum power at the same time. So it may be that you're connecting a device that requires 50 watts, but the switch port can only provide 30. And these kind of testers are now able to check that and actually measure the power that the switch is able to provide. And maybe last but not least, in the world of fiber, because products like OLTS and OLTRs, they're relatively high-end products costing more than 10,000 euros or pounds even. And at the very other end of the spectrum, there was like a 120, 130 euro fiber alert, which it's almost like I don't have one here as I show, but it's almost like a pen.
Yeah.
You can wave it in front of a connector, and it'll tell you is there light or not.
Right.
And of course, a lot of the optical fiber communications as they occur, starting at 850 nanometers and up, that is in the non-visible light spectrum. So you also do not want to look with your eye into that, because although you can't see it, it can still damage the eye. And a basic troubleshooting tool like that fiber alert, waving it in front of a port or in front of a transceiver, will actually say if there's light coming out of it or not.
Okay, so that's really interesting. Then that's a new product you've got. Kind of sounds like an old vote stick.
Well, yes, it
Yeah.
is. The form factor is actually the same.
Right.
So that if you have the volt alert from Fluke and the new fiber alert, they from a case perspective, they almost look identical.
Uh-huh.
It tells you, is there light or not. So yeah, and it's nice to be able to detect active fiber signals, so you can actually not only test if there's light coming up, but also check polarity.
Yeah. So I guess that the fiber alert could be the very first port of call that you go to your toolbox, because it gives you that indication quite quickly.
Yeah,
absolutely.
And it fits right in your pocket, right?
Well, that leads me on to another question. So, what are the common faults that occur with data comms, and is there any advice that you offer?
Yeah, so I guess the first the first error that occurs are typical installation faults, right? And to connect, and I think in copper here, if you connect twisted pair, whether you like it or not, you need to untwist it. And by untwisting it, you change the physical characteristics of the cable. And the more you untwist it, the easier it is to terminate, and the worse the performance gets.
Right. Okay.
And frequently it goes wrong there, especially with people that are not so skilled of how far exactly you need to untwist it to make a reliable connection with a punch down tool. So that is one thing. The second thing that happens is that the cable gets installed properly, it gets properly terminated, but they use the wrong category connector. So, for example, they have Cat6 cable installed, but they terminated with 5E. And people didn't look, if they had the right stuff there. Then we spoke about the project manager setting up the tester correctly, right? But there's a lot of problems happening in the setup phase, especially when this setup takes place in the field because there is the pressure of getting started,
Hmm.
and there is additional stress in the field. So that's also why if you talk about recommendations in that area, we spoke about the project manager doing that. Let them do it in the office when it's nice and concentrated,
Hmm.
uploaded. Nothing can go wrong at that point. If you do it in a stressful environment in the field, and sometimes these certifications take place while 5 meters away, people are using drilling machines.
Yeah.
The other day, I heard about a story where people were installing fiber in a data center, a new build here in Amsterdam, and they were still doing building and construction work. Well, think about dust in those cases, right? So it's like, yeah.
Yeah.
So yeah, then there is the regular stuff if cable can get damaged. Sometimes cable gets pulled some places and the insulation is stuck around the corner. So they pull even harder, and then obviously they damage the insulation, and they could damage this. Actually, get the pairs damaged as well. The marginal test results is another one. I touched on that just minutes ago, but yeah, these are likely to cause problems in the near future. And I think the other one is, if you do not decide to certify using the permanent link model, then you're setting yourself up for a lot of other failures. So the
Okay.
recommendation is always test the permanent link. The permanent link is what actually runs into the wall. It's in a patch panel on one end, in a central cabinet, and it's in a wall socket at the other end. Test that with a permanent link adapter, and you're good. Some people insist on doing channel measurements. And if you do channel measurements, then you can have up to 5 meter patch cords at either end.
Yeah.
And the minute you certify that way, you actually need to leave those patch cords in place.
Okay. Yeah. Yeah.
But there's a very high chance that that doesn't happen. And then by replacing it with another patch cord changes the characteristics of the link that you just tested.
Absolutely. Yeah.
So
So
these are like big problems that can occur then, because when people go back and look at the performance of a link, they say, hey, the link characteristics will change. What's going on here? But it could be as simple that people use different patch codes.
different patch codes, yeah. And if they're getting used all the time, there's always the opportunity that they can become damaged. It changes the whole integrity of the installation as well.
Correct.
Robert, this has been such an interesting conversation about datacom. Sometimes we feel that it's the hidden art form behind keeping everything together, and it's not often that we get to talk to experts within this area. So I really do thank you your time today, coming to talk to Design Spark, sharing your knowledge with us, giving us some ideas around the products that Fluke obviously use to help datacom engineers do their job on a day-to-day basis. So I'd just like to take this opportunity to say thanks, and I hope we talk to you again real soon on Design Spark.
It's a pleasure, Rick. Thank you.